Hello and welcome back to the DataUNet channel. I'm Tseko and today we will discuss about the different machine learning methods and some performance measurements that will be used to measure the performance of the machine learning models. If you like this kind of content and want to learn more about machine learning, please make sure that you like this video and also subscribe to the channel. There are four categories of machine learning models, and those are supervised, unsupervised, reinforcement, and semi-supervised machine learning. We will discuss each of them in the following slides. So, we'll start with the supervised machine learning algorithms, which are used when the output should be classified or predicted. Here, the algorithm learns from a historical data, which normally is referred as training data. The model is trained on this training dataset, and once the training is done and we are satisfied with the performance of the model, this model can be used on the new data in order to predict the values for the desired feature. This means that the learning of the algorithm is monitored during the training period, and once the model reaches a performance that is satisfactory for the needs and is verified with the help of a testing dataset, it can be used for the classification and prediction problems in the future. Such examples where this type of algorithms and models can be used are image classification or market price prediction. So, in the first case, if we want to create a model for classification of images, we will train the model on images that we have already in possession. So let's say we have a set of images of cats and dogs, and the problem will be to distinguish what is a cat and what is a dog. So we will train our model feeding information, so feeding images about cats and dogs with labels. So we'll have one image that is cat with a label cat, and another image which is dog and also labeled as a dog. And based on this information, the algorithm, when we feed a new information, so a new image, will be able to decide if in the image there is a cat or a dog. Also, in the second example about the market price prediction, this can be used for, let's say, we have already some information about the prices of the assets that are in the market, and we'll train the model based on the historical information, and then we'll feed some new information. Let's say we want to anticipate and to see what will be the price of a house in some location. So we'll input the parameters, but we want to know what is the final price of the house. And based on the previous information, where we had the parameters about the houses and also we knew which is the price of the house on the market, we can also define the new price of the new house. So this is how we can use these types of models, because we are supervising them while they are learning the features and how to predict and how to classify the information. On the other hand, unsupervised machine learning models are used when there is a need to organize or classify data based on the features for the records. But the only difference with respect to the supervised machine learning model is that the training dataset does not contain the output value, meaning that there are no values for the dependent feature. This means that the model needs to understand the data by itself and reach some conclusion. So, in this case, the model will run many and many times and perform many iterations on the training dataset until it reaches the desired performance goal that has been given to the model by us. After the performance goal is reached, then the model will be tested on a new dataset, which is called, again, testing dataset, in order to check again the performance of the model. So we have once, and then we check again the performance of the model. These models are more complicated to be implemented with respect to the supervised machine learning models, but are good for problems where we don't have good knowledge of the information provided in the dataset. And in this case, it will leave it to the model to make sense of the information and to provide us a solution. On the other hand, reinforcement machine learning models, which are quite interesting and also quite difficult to be implemented, use trial and error method to find the right output based on the highest rewards. So the output of each iteration of the model is compared to find errors and feedback which are imputed into the model to improve or maximize the performance. So in this case, the model will be either rewarded or punished based on the performance. So if the performance increases, there is a reward for the model. If the performance decreases, then the model is punished. And this will be repeated until we get the performance goal that was given to the model. These types of machine learning models are normally used into robotics. And then the last type of learning machine models are the semi-supervised models, which take labeled and unlabeled data, where the amount of unlabeled data is bigger than the amount of labeled data. It is a combination of both supervised and unsupervised learning models. Hence, this is why it is called a semi-supervised machine learning model. The data in the dataset may contain some already labeled, let's say images of dogs and cats, as we said before, and a lot of unlabeled data that the model will need to label during the learning process. So this is a type of combination of two types of models, which is rarely used, but it's very important to know that also these types of learning machine models exist. Now that we covered the various types of machine learning models, let's see how do we measure their performance using some performance measurements. Since we have classification problems and regression problems, there are also two types of performance measurements. Performance measurements used for classification algorithms and performance measurements used for regression algorithms. So, when we are working on a classification problem and a model needs to be verified, the performance measurements used to evaluate the model are accuracy, precision, recall, and F1 score. And for the purpose to understand better these four performance measurements, we will use the image on the right, and we'll start with accuracy. So basically, accuracy is calculated as the fraction of predictions correctly predicted from the sum of all predictions, which means that we will look for the main diagonal, basically the sum of the true positive and the true negatives, and divide that value with the sum of all the other values. So we'll divide with true positive plus false negative plus false positive plus true negative. Then precision is the accuracy of positive predictions. So we'll take in consideration only the true positives divided with the sum of true positives and false negatives. So basically we'll consider the first column in the picture. Recall is also known as sensitivity or also as true positive rate. So it is the fraction of positives that were correctly identified. So it is calculated simply by dividing true positives with the sum of true positives and plus false negatives. On the other hand, when we are working on a regression problem, we can use one of the following methods: R-squared, mean absolute error, mean squared error, or root mean squared error. And in this video we'll understand the logic and a little bit of mathematics behind the calculations. Now, let's see how do we calculate the R-squared value for our model. And in order to calculate this value, we need first to calculate the regression sum of squares, error sum of squares, and the total sum of squares. So if we look on the photo on the right, we will see the red line, which represents the average value of the ground truth. The ground truth is basically the information that is known to be real or true, which is provided with direct observation and measurement. This is also known as an empirical evidence because it can be provided simply by looking at it. Then we have the green line, which represents the prediction made from our model, and the blue dots represent the data points from our training dataset. So the regression sum of squares represents how far the line that represents the model's prediction is from the ground truth, or simply said, the distance between the green and the red line. The error sum of squares represents the sum of the distances between the blue dots and the green line. So first we calculate the distance from the predicted regression line to each data point, in our case the blue dot, and then sum those results. And the total sum of squares quantifies how much is the distance between the data points, the blue dots, and the horizontal line, the red line. This value is calculated by calculating the sum of the error sum of squares and the regression sum of squares. And once we have all of these calculations, the R-squared value is calculated simply by dividing the regression sum of squares with the total sum of squares, and this value should be in the range from 0 to 1, and for better results it should be closer to 1. Mean absolute error is a measurement which measures the average of the absolute difference between the real value and the predicted value for each record in the training stage. This means that if the real value of y is 5 and the predicted value of y is 6, the difference will be 1 for that record. This will be also the same if the real value was -5 and the predicted value was -6. The difference will be again 1 or -1, but since we are taking the absolute error, the absolute value, it will be always positive. And we need to do this for all n records and sum all of them together, and then divide that value by n, which is the number of records. Then we will get the mean absolute error for the model, which if it is closer to 0, the better the model's prediction is. A similar performance measurement to the mean absolute error is the mean squared error, where instead of calculating the absolute average, we measure the average of the square difference between the real value and the predicted value. So we simply calculate the difference between the real and predicted values and find the square of that value. We repeat this for each record in the dataset and sum the n squared values and divide it by n, which is the number of records in the dataset. Again, here, if the result is smaller, the performance of the model is going to be better. Here we can also cover the root mean squared error method, which is done simply by calculating the root value calculated with the mean squared error method. So here also the result should be smaller in order to have better performance of the model. So these were some of the performance measurements that are used in order to evaluate the machine learning models. And in the next video we will talk about the linear regression algorithm. Please leave a comment if you have any questions, and thank you for watching this video until the end. See you in the next one. Bye bye.